Welcome to E Squared Emporium for all things AP Psychology. Today we're going to talk about selecting your sample. So, how do we find your victims? Your participants for your study. That's what today is all about. So, we start with the larger population. What is the group that you want to study, the people or the animals that you're studying? These are called your participants, the people who are going to be in your study, because we cannot study the whole population. We cannot study the whole world. So from the larger population, we select a sample. So we write this out in a research study. Population is a large letter N, capital N. Sample is a lowercase letter n, as you see here in your slide. So the sample is what we pull from the larger population. And it needs to represent, to be a representative sample, it needs to accurately reflect or represent the entire population. We'll look at a couple examples here. So there's our population, there's our sample. It should reflect and represent. It's not all blue, it's not all red. It should accurately be balanced. Here we have M&Ms, population and sample. So the M&Ms that are in your hand should reflect the population that's in the larger bag. And they don't melt in your hand, right? Just in your mouth. And here's the population and here's your representative sample. See how the sections of the pie chart are about the same, even though the numbers of people in the representative sample are not the same. It is the same part of the pie chart, so representatively, proportionately. And here's an example with percentages. Representative sample, it should represent the general population. So we start with 12 females. Let's say this was your class breakdown, 12 females, which are 75% of the class was female. So we're going to select 6 females from that ratio, which still is 75% female. Let's say there were 4 males. They're a little outnumbered in this class. So it's 25% male. So we're going to select 2, which still keeps it 25% male. So we can't go to 50-50. Well, that would be 100% equal. That is not a representative sample of that particular population. Sometimes we look at a target population. That's a specific group you want to study. So if you're studying twins or single parents or bilingual students, that's the specific population you're trying to target with your study. So a random sample is typically the very best way to select your participants. It minimizes most bias. Everybody has an equal chance of taking part. This is how jury duty is selected. So you could put names in a hat. You could have a computer-generated system. You could draw index cards, popsicle sticks, so forth. Every member of that target population has an equal chance of selection. So one advantage, it is great, as I said, for removing bias. It assumes that the group that will be chosen has the general characteristics of the entire population. You have the best chance of getting the population represented by doing it this way. Random assignment is how we assign participants to either the control or the experimental group. And we also need to do that at random to minimize bias. It will also increase the chances of equal representation in the group. Let's say your teacher is splitting you up, but she kind of splits you up either by gender or by strength in class or by your highest test scores. It's hard for human beings to be completely random in the way that we do this. It's better if, say, the computer generates this, or you use index cards or some other method so that each group has an equal chance of having a certain amount of randomness, right? So first we draw the sample. Then we draw the assignment, and both should be random. And we're going to look at random assignment versus random sample, and we'll do some activities in class about that. That is a concept that students get a little confused about. So again, random sample is the method of how you choose the participants from the population. And then random assignments is how you assign them to either the control group or to the treatment or experimental group. A stratified sample kind of comes from geology. In geology, they use layers of sediment and rock and sandstone and limestone, like this picture that we have here. But how we do this in psychology is that we take from different groups or layers of people. So let's say there were 4 groups in Winston-Salem that we needed to consider. So from a stratified sample, we would take an equal number from each of those layers or each of those groups. So it's stratified. So for instance, let's say you want student council at your school to have equal representation from each grade level. So you would have 5 9th graders, 5 10th graders, 5 11th graders, 5 12th graders. It would be stratified and it would be equal from each of those levels. So a sample is drawn from each of the separate strata of the population. And again, that should be representative of that group. You could do um, by gender. You could do by age. You could do if you were doing the racial makeup of Winston-Salem and you wanted input, or you could do by subdivisions, smaller towns around Winston-Salem. You could do religion if you wanted to have everybody's input. So there's different ways we can stratify. Convenience sampling is probably the way most of us do this in school. Data is collected from an easily accessible and available group of people. Like, hey, you want to be in my study? So the individuals may not represent the entire population. That's the problem. If I ask you to go do this study and you're a soccer player, you're probably going to ask the entire soccer team. So the results are all going to be athletes who are on the soccer team who have had a similar experience to you. And so that is not the general reflection of the entire population, but they are the most accessible to you. So if you go to the mall, say in the middle of the day, it's convenient, but those are only people who don't have a job and who have the time to go shopping and who enjoy shopping in person at the mall. You've left out online shoppers, you've left out people who are working full time, you've left out a lot of other different categories. If you only ask your friends at lunch, right, that's kind of a biased sample. It's convenient, but you're not getting everybody else at all the other tables. So those are some ways convenient sampling. If you go out into the hallway and you just grab whoever's in the hallway right now, it's convenient, but those might just be the kids who are skipping class. They might not be the kids who are great at math. It's hard to know. Or kids on the way to the bathroom. And you don't always want the people who are the most eager to participate. The one who's always got his hand up in the front row, the one who always wants to be chosen, the one who always wants to participate. There are people who do a lot of experiments. You know, you do get paid when you're an undergraduate in college. You get paid to participate. And so do you want the person who's been donating blood 5 days a week to be in your experiment? Do you want the person who just did a shock therapy experiment to be in your experiment? So they're the most eager, but the people who have nothing else to do but come answer questions for you, that may not be the group that you want. That may not get everybody. You probably get more extroverts. You leave out the introverts. You get people who have plenty of free time. You leave out the people who are busy. It does not represent the entire population. Yeah. Ooh, 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 pick me, pick me. So this leads us to sampling bias. Um, and in this picture, yes, I love responding to surveys. No, I toss them in the bin. Wow, it looks like 99.8% of the people who love responding to surveys, they're the only ones who answered it. So they're the only responses that you got back. So that shows bias because you don't know about the other percent that threw them in the bin. So sampling bias occurs when members of the population are more likely to be selected over others. And we'll look at some different examples of how that can happen. Well, why is this important? Why do we care? Well, it gives us a flawed sample. It gives us flawed data. It tells us that we can't really generalize the findings back to the entire population. If you only chose students who are really, really good at math, you can't generalize that data back to the entire school. It is not a representative sample, and that's why we try to avoid bias in all possible ways. So here's another example. If you only used people who were NBA players who are 7'5", 7'6", 7'7", you would have selection bias. You would say, oh my goodness, look at how tall all men in America are. All men in America are 7'5" to 7'7". That's amazing. But we can't generalize that way. But actually cars would be designed for the person who's 7'7". Doorways would be designed for the person who's 7'7". It would radically change life as we know it. We we tend to take an average of what the size is. And this is not the average. This is just the average of NBA players. So you see how that would lead us to a sampling bias. What if we only sampled people who were over age 65 and they were going to make all social media tech decisions for you? Would you like that? Would you like only people over 65 to decide about YouTube and Snapchat and whether or not TikTok gets to exist and X and so forth? So, would their answers fairly represent how teenagers use social media and why teenagers use social media? This guy down at the bottom, he gave up. He went back to a landline. He totally gave up on social media. I don't think that would be fair. I think that would be sampling bias. So, how can we avoid sampling bias? Well, the best thing we can do is random sampling. That's the most trusted method. This way, you don't have any control over who's included. It's random. And the second best way would be stratified. That can also have some equality. So, depending on what you're trying to do, if you want to make sure every strata or every layer or every group gets represented in, say, a county vote, you would want stratified. So those are two ways that we can avoid sampling errors and sampling bias. In the end, we want to be able to generalize our findings to the greater population. Doing all this research, if we research on mice but we can't generalize to humans, then not sure that we really did, we really laid out our research there quite ethically. So we want to make sure that all of our findings can not just relate to the target group, but can be generalized back to the general population. And this is what we're going to talk about statistical inference in a later video. So for instance, we have this lovely group of young men, and we go in and we do a covert observation of how this lovely group of young men live their life. And then we want to generalize it to these lovely people at the nursing home. Do you think we can generalize the one group to the other group? Or vice versa, right? Could we take life in the nursing home and generalize it to life on the streets? I don't think we could. So we want to make sure that what our findings are finding are results that we can generalize back to the entire population. All right, so now you are prepared for class. And please wait and hold off there, and we will do the rest together. So that's all for now.